His Google Scholar H index is 38, I-10 index is 111, and citations are 4,790. So far, he received 55 research grants, supervised 25 PhD, 80 MSc, and 65 undergraduate students. He is listed as top 2% scientist in the physics worldwide in 2020. His recent research interests are in advanced optical materials, statistical condensed matter physics, nanomaterial synthesis and applications, including nanobiomedicine, laser physics, simulation modeling, as well as nanoscience. One of his major concerns, rather than research pursuit, is the social impact of science and technology on environment, marginalized societal groups deprived of higher education, and the imbalances thereupon in the distribution of its fruits and adverse impact on these stakeholders. Now, I would request Professor Ghoshal to deliver his lecture on the topic entitled Life and Light Today and Tomorrow. Sir.
Thank you so much. Let me share the slide. Can you see the slide, please? Hello?
Yes, sir, it is visible.
Can you
Yes, sir.
see?
Yes, sir, it's
Yes,
open.
sir.
Yes, sir,
Yes,
please.
sir.
Thank you so much. Yeah, it's a great pleasure for me to be here today. And I'm really thankful to Dr. Manish for constantly discussing with me all this thing over last almost 2 years or so through an international conference last year, I think. So he asked me to deliver a lecture where the gathering would be undergrad, master's, and PhD student. So therefore, I chose a topic on which I have been working for last 2 decades almost, and this is light and life today and tomorrow. So in this particular lecture, what I'm going to argue that scientific research on material science is very much needed to develop human-centric lighting system. And I'm going to show a close connectivity between light and life processes and the problem we have created through the modernization of technology and to prevent those adverse impact on human health and mankind, we need to develop new materials and new technology for tomorrow. And that is going to be the main part of my presentation. So here we are today to have a possibility of signing MOU with Ghoshal University. And I must tell that this kind of webinar and constant research is needed before we go for MOU, because UTM is a massive university with 38,000 students, about 1,600 academic staff, 1,500 non-teaching staff, 11,000 international scholars, and huge facility. And also it's one of the topmost ranking university in Asia and over the world. So we need to go through this kind of exchange program for future collaboration. So thank you so much for arranging this kind of lecture. And I'm now going to present the lecture. So in the outline, because the time is 1 hour, I'm going to talk a little bit about the light and life, of course, from the scientific viewpoint, then how the human vision is connected to light and how the life is connected to human vision, then natural lighting environment, artificial lighting environment and the problem caused due to the modernization, particularly a lot of gadgets and electronic devices. And I must tell, the post-COVID era is more dangerous, where 33% increase in the eye disease because of children started using the tablets, phone for online classes. Now it is very, very acute problem all over the world, vision problem. And the myopia prevalence and prevention are therefore needed. I would be talking about the need of material research for developing new kind of smart light sources, which are essential for nutritional lighting. And that would be the idea of this lecture. And to come to light and life, first thing is that we detect light through our eyes. Eye is the most sophisticated detector with billions of neuronal cells and ganglion cells connected for the interpretation, perception, and sensation. And the beauty of human eye that we can perceive almost like 3,82,000 different colors. And that's the power of eye. And out of all these, our sensitivity of eye is maximum near the green and yellow region. And that's why the signal color, the road signal color, and most of the important color are green and yellow. Red colors are also used in the signal due to lowest Rayleigh scattering, because Rayleigh scattering cross-section is inversely proportional to 1 by lambda to the power 4. And what is light? Scientific sense, light is most refined form of matter, as commented by Louis de Broglie, where he got the Nobel Prize due to wave-particle duality principle. So that's all about the beginning or the introduction of this lecture. So in this lecture, I am going to show you the light is an integral part of life processes, our sleeping habit, our hormonal secretion, our brain function, our responses, our performance, everything. Animal as well as plant, all living processes depend on light around us. And why do we need human-centric lighting system? That I am going to show that there is need. Something went severely wrong with the modernization, and that's what we are talking about, this human-centric lighting system, and we are trying to understand the correlation between light and life. So usefulness of light, if we look at for life on Earth, we must know that light appeared 300,000 years after Big Bang. And Earth was formed 10 billion years after light appeared in the universe. And life on Earth came 3.5 billion years ago. Since then, life and light are interconnected and operational. Let's argue, what is the use of light? For plants, light provides energy and so-called photosynthesis. If it is not there, no animals will survive, because all the food of animal come from plants, and plants survive because of light. So light regulates the biorhythm, so-called photoperiodism, and that's the use of light for plants. For animals, we have two kinds of use of light. One is called image forming effect. Light is necessary to visualize the surrounding world. And second, called non-image forming effect. Light regulates the circadian rhythm, hormonal system, and sleep time. If we look at life on Earth, then life is broadly divided into three categories: bacteria, archaea, and eukaryotia. We have no useful definition of life, but this is the hierarchy of life, where animal fungi, and plants are sitting at the top hierarchical position. And if we ask when human or Homo sapiens came on Earth, so far we have the record that oldest skull is found in Samba Valley, and the age is 200,000 years before from the present time. So that's mild introduction about light, about life on Earth. Now, this is an interesting book to read, which is published in 2013. It's talking about the story of human body, evolution, health, and disease. Amazingly, we are in 21st century. We are going to a point where we are same as that where we started, like from the chimpanzee. So our evolution started with chimpanzee, and due to the advancement of computer technology and electronic gadgets, we are also posing and our gestures in coming into the same pattern. And here is the point that I call today, something is wrong. Now question is, what tomorrow would be? That would depend on our research, our application of research on human-centric lightning system. If we can develop, then there would be probably a remedy of this, and that would be the connectivity of light and life with today and tomorrow. Let's look at, in the ancient time, light was only fire and sunlight. People lived in Greenland, hunted for animal, lived on plant food, mostly raw. Occasionally it was burnt or cooked in the fire. Fire came from the plant wood. And then when humans started getting knowledge, produced the candle. Again, the candle was the main source of light, together with sunlight. Long before, the premature death was due to starvation, sanitation, infectious disease, and physical exhaustion. But nowadays, the main factor of disease is obesity, eating too much, too clean. Look at the sanitizer, look at the mask. And the disease are due to that. Extra caution, extra medication. Now look at, something somewhere is going wrong, and we need to revert this situation. Physics play a very important role. Material science play a very important role. Let's quickly go back to light. What we know about light. Look at, light was not known. Scientific evidence of light was not clear till 17th century. 1960s, first Isaac Newton proposed the corpuscular theory of light. Then Robert Hooke and Christian Huygens with Young, they proposed the theory of wave of light. And then in 20th century, Louis de Broglie proposed, Einstein proposed, light can be also particle. And that is the way we came to know about the scientific aspect of light. But for human being, for living organism, light is extremely important. If you look at the primary source of light for the biosphere, which is sun, solar system, and this is the way the balance of light and energy of the solar energy goes on the earth. And if we can store, if we can convert one day light coming from the sun on the earth, it can be worthy for 1 year electricity and energy consumption in the whole world. So one day sunlight is equivalent to that amount of light. One can show by doing the calculation. All right, that's all about light. Now question is, how we use light for our everyday life? Well, we produce artificial light emitting devices, light emitting sources. Well, in the old days, it was incandescent house lamp, but now it is fluorescent lamp and white LED. But question is, based on what factors these lights are good for health or bad for health? So all depends on spectral power distribution and the color temperature of light source. If the color temperature of light source is very high, we consider those light as cool. If the color temperature is low, we consider that light is hot and bad. So fluorescent lamp has 4100 Kelvin color temperature. So it is considered to be the best so far, whatever we know, for human purpose. However, if we look at the tungsten lamp, with the change of wavelength from blue to red, the heating increases constantly, and therefore it is not good for living because it creates a lot of greenhouse effect inside the room, and which in turn affect human health. Blue skylight, which is the natural source, is the best one. Now question is, can we create blue skylight inside our closed door room, inside the indoor? If we can do it, then we can solve many problems, many health related issues, many diseases. Human health will improve, and that I am going to argue in next few minutes. Now question is, how do we see? Light is the stimulus for our vision. Light is characterized by wavelength, frequency, and amplitude. And from the sunlight, a very narrow band of spectrum is visible light, and that is causing all this wonder and colorful, beautiful nature. So we see things because materials and objects reflect light in our eyes. We don't see light. We see objects because of light. This is literally the way to get to see things. All objects we see create light or reflect light. Most of the light emitting material, they create light. Most of the object we see around us is due to the reflection of sunlight or artificial light from them. Now, how do we see light? We see light because of eyes. Why eyes can detect light? Because eyes has rod and cone cells. So any disturbance in the light properties, such as frequency, such as color temperature, wavelength, can cause a defect to the rod and cone cell, and that we call as eye disease. And because of that rod and cone cell problem, the whole ganglion cell and neuronal system get affected. And that's the way brain disorder, heart disorder, kidney disorder, all disorders in the body are connected to the light, connected to our vision. And that's the way light and light processes are strongly connected to each other. How many rod cells and how many cone cells are there in the eyes? This is the number of rod cells, nearly billion. And this is the number of cone cells, also millions. And these are causing the main sensation and perception in our eye. So human visions and sensation to light are connected. And this is connected through perception, through the data reduction system and transducers. So we have sensory system, we have mental process, we have detecting system, and we have transducers that convert energy from one system into another. And we have artificial transducers, we have natural material made transducers, and now nanotechnology is going to create those sensors and transducers for better eye disease protection. But we are talking about not the cure. we are talking about prevention. That means at the level of light sources, if we can create better light sources, then we don't need any kind of preventing or curing devices. So it is therefore important to create natural lighting system, which I call human-centric lighting system, for better sensation and perception. So human vision is the key issue for light. Key sense, visible spectrum, creation of visible spectrum using material science and nanotechnology is the important part of research that we need to do. Photoreceptors, lens, cornea and retina in the eye need to be protected, where the light source play an important role. And to get smart light sources, we need to produce a lot of nanomaterial. Nature material cannot do it. Man-made metamaterial, man-made artificial material, nanocomposites, nanomaterials, quantum dots, quantum wires, nanocomposites, nanohybrid materials can do it. And that's where nanotechnology come into play for the human vision correction and protection of human eyes from several types of eye diseases. Now, question is, what is the way materials must be generated to create better color, better emission, better color temperature on that? So there are two parts of vision on the material that can take care of. One is called the physiology, which takes care of the spectral sensitivity function of our eyes. So material can take care of it. And color matching function, which is also a property of the material and property of the control of the material, so that we can control the hue, we can control the brightness, we can control the saturation of material color. And that is the way we can create nutritional power source, nutritional light source, and we can therefore cure or we can prevent eye disease. So these are the two perspective of human eyes vision. One is called the physiological perspective, other is called the psychological perspective. Physiological perspective depends on the spectral function, and psychological perspective depends on the other parts of this. And here, cool white LEDs, CW LEDs, play important role. If we can create cool white LED, which is the biggest challenge in 21st century for material scientists and engineers, so far we are not able to create a cool white LED very close to natural sunlight in blue sky. If we can create it, we can solve all problems, almost all problems related to vision. And that's where this should be a gift to humanity. Now, vision problems are broadly divided into four types: hyperopia, myopia, astigmatism, and presbyopia. All these caused by the defects in the retina, defect in the lens, defect in the corneal cell, defect in the ganglion cell, defects in the rod and cone cells, damage. And this damage comes from brightness of the light, hue of the light, and saturation of the light. Wrong saturation, wrong brightness, wrong hue. Most of the cheap mobile phone, most of the cheap tablets, most of the cheaper laptop and desktop, and post-COVID era, 33% increase, recent report of WHO and UNESCO shows that 33% increase in the eyesight problem within last 3 years after COVID, due to only online classes, usage of lot of devices at home at a time. Children are 8-9 hours hooked into laptop and tablets. And we are also working 15 to 16 hours in indoor artificial light, sometimes bright light, fluorescent light, weak light, and all this is related to human health. Ultimately, human health suffer. Health suffer means everything suffers. And this is the thing that I am going to tell you. Describe the chromatic light. Chromatic light, that means colorful light, is described in terms of radiance, luminescence, and brightness. And these are the things which come from the control of material properties. And if we create material using the root of nanotechnology, then we can control them. So therefore, we can get better material for cool white LED. And our group has been working on these for last 10 years or so, and we have been working on most of the optical materials to create better and better light emitting devices, lasers, sensors, detectors, optical sensors, optical communication devices, and also cool white LED and white LED. So these are most of the priority area of science and technology all over the world. Even India, I have seen Department of Science and Technology, University Grant Commission, CSIR, almost all the projects are sanctioned nowadays based on these, because this has directly related to health and hygiene. When health and hygiene is protected by the material science research, recently India also created, really the government is doing so well, created the clean room in two places, as I know, in Rajasthan and also in Bangalore. India is going to produce mass scale computer chips and so on, semiconductor chips. And my friend and we are also collaborating with some of the groups through ASEAN project. My purpose of telling you all must write the ASEAN project in collaboration with us, with Singapore and with Malaysia, and it is now also DST. Last year we got DST on, and this year look at the priority area, apply for the ASEAN grant. Many of you can apply also for 6 months visit through DST with a fellowship of $5,000 for 6 months. Many are visiting in different countries for collaborative research. This is the only way we can help each other. In fact, I am ready to help all my Indian friends and colleagues, because that is the way I can only serve the nation staying from outside. Through lecturing, through helping in research, through collaborative research, you are all welcome to do so. And that's the purpose. Even research scholar can take DST project, or they can apply for DST 10,000, 15,000, 20,000, 100,000 rupees, and can come here for 1 month, 2 months, 3 months. In fact, DST, CSIR, UGC, nowadays they're giving a lot of funding. Many students are coming, as I can see, not like our time as before. Now, everything is changed, and particularly Garhwal University and so on, you will get extra government fund from DST and CSIR, UGC, and you must come and visit. And you can also do collaborative research sandwich program with our university. And that's the way we can go way forward. So characterizations of colors are needed, material research are needed. Any student doing materials research in nanoscience, in lasers are most welcome. Sensors, biomaterials are most welcome to collaborate with our group. And that's the way I can help and I can collaborate with you. Now, question is, can we define numerical numbers or numerical facts with light, with vision, with hue, with brightness? Answer is yes. Here is the role of Commission Internationale Éclairage. This is a commission which takes care of almost all the light sources developed in the world before it goes to practical applications and before it takes the marketplace commercialization. Otherwise, if the wrong light is marketed, then human eyes can be damaged. And in fact, many countries are producing cheaper light sources. They are giving in phone, they are giving in tablets, and those people who are buying cheaper mobile phone, cheaper tablets, they are thinking they got it cheap, but ultimately it is leading to their eyesight problem. human vision, particularly young kids and children are very susceptible to this kind of disease. So we need to protect it. And that's where the knowledge of numerical representation of color, the knowledge of light sources are very much needed. And as we know, we get white light through the mixing of RGB color, red, green, and blue. And blue LED discovery got the Nobel Prize recently, and white LED has created now a revolution in the world. Here is the CIE chromaticity diagram. Any light source we see around us, including sunlight, including candlelight, fluorescent lamp, vapor lamp, any light source can be mapped into this mapping, which is called chromaticity diagram. Any student, any lecturer is doing any research, optical research on optical properties of material must do CIE plot to see where is the qualification of the material, whether the material qualify the properties or not. Now, as you can see, the biggest challenge of humanity is to hit at the center of the white spot. If anyone can hit in single material, maybe a Nobel Prize is waiting for that, because that would be the absolute and ultimate goal of humanity or science research, to develop that kind of white LED, because that would lead to the highest color temperature, highest chromative index, and that would be the blue color white light under laboratory condition. And that would satisfy 8,500 degree color temperature, Kelvin color temperature. And we are looking, nanotechnology is probably the most promising route to get that kind of white LED material. Here is the connection of tomorrow, where we are going to lead through material research to produce some kind of light emitting devices that will solve the myopia, eyesight, vision problem. So reading is important, because most of the eye problem comes from close reading, small letter reading, and also in darkness reading, in low light condition reading, in bright light condition reading. So computer, cell phone screen are the most damaging devices if the light, brightness, and hue are not properly adjusted. So amazing thing about human vision, please read this slide. I encourage all of you to read. Please read it and see how our eyes are amazing, how our brains are amazing. Please read it quickly. I am sure within 1 or 2 minutes, you can all read. I couldn't believe that I could actually understand what I was reading. The phenomenal power of the human mind, according to a research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letter be in the right place. The rest can be total mess, and you can still read it without a problem. This is because the human mind does not read every letter by itself, but the word as a whole. Amazing. Yeah. And I always thought spelling was important. But now this slide tells you how smart our brain cells, neurons are, how smart our eye are. All word spelling in this slide is wrong, but still we can read without any problem. But my only request, do not tell this to the kids, because they will write misspelling in the school and they will argue with teacher and parents. You told one day anything we can write. As long as we are reading, it is okay. But that's why we must know how important to protect our eyes from a wrong light signal. And that's where human-centric light is coming into play. So we are now going to talk about natural lighting environment, which I call human-centric lighting solution, and create uniform background on the working place. here is the blue scalar light. And you look at blue sunlight scalar light is 2000 to 10,000 lux. Question is, can we create a material which can produce this in the red, green, and blue wavelength? Can we control that particular material for hue, brightness, and color chromaticity? If we can, then we can create a visual illuminance in these kind of spectral distribution, and the observer will be close to 2 pi steradian. That would be the shadow-free luminescence, and we will reach our ultimate goal, so-called cool white LED using man-made nanomaterial. And that's the creation of day sky properties inside indoor, inside our classroom, inside our hospital, inside our bedroom, inside our study room. If we can do it, we are there in the game. That's where my lecture is. So to get that, we need artificial light source, because sunlight we cannot use 24 hours inside the room. Sunlight is only for few hours, particularly during the winter time in your place. You are in the hilly place, still okay, but evening is waiting to come soon, so sunlight will go. If you have electricity problem, then whole night we have to be in trouble. So can we create low power source, light source with blue color sky effect? If we can, that would be our ultimate goal, and that would be the cool white LED material using nanotechnology. So research is needed. So what is the revolution in last few years called third revolution of light source? Look at incandescent lamp, go from yellow to white region, halogen, TFL, CFL, then replacement of light by white LED. I'm sure that still in India, many places people are using ordinary bulb because it is cheaper, tungsten bulb, but it is dangerous. In our time, we had only this. Even fluorescent tube light just started coming. Then white LED, I do not know how much percentage in India is using in the room. But important thing is 2014 Nobel Prize in Physics has gone into this. Blue LED, a gateway to bright and energy-saving white light sources. And now, natural light, day color, sky, blue light from solar source. Like that kind of light, we have not created yet. So how do we create? What we must know to create it? We must know about one thing called color rendering index. If we create a material, look at the color rendering index. It has a scale between 0 and 100. If we can reach a material whose color rendering index is 100, that means we have reached to the sunlight, clean sunlight, shiny sunlight, blue sky, daylight condition. And if you look at this scale, look at the evolution of all the light sources starting from LPS, starting from the halogen vapor lamp, sodium vapor lamp, to till today, incandescent and also fluorescent lamp. We are not able to reach color rendering index 100 with all brightness, hue, and saturation like sunlight. And that is our ultimate target. I call it future. So if you look at the conventional lighting system nowadays in big hotel, big restaurant, big auditorium in India, for example, if you go to Delhi, Kamani Auditorium, or big hall in the big places, Memorial Hall and so on, you will get the best light. Even that best light will not satisfy the world-class light. So we need more. We need color rendering index very close to 100. If you look at the best, richest people bedroom condition, even the comfort is low, illuminance is low, glare is there, and the most important, no circadian signal. Remember, circadian signal is life process, and light is closely related to circadian signal or circadian rhythm. Artificial light sources so far is not able to create circadian signal. What is circadian signal? To know that, you have to know few things. You have to know different parameters, different standard called lux, illuminance, called solid angle. So circadian rhythm is decided by all these properties of light together with color rendering index, hue, saturation, and brightness. If we can control all this, only it can be controlled in man-made nanomaterial. Here is the white LEDs coming. White LED, so far the best white LED has created 5,000 to 6,500 Kelvin color temperature. It is not able to go to 10,000 or 8,500. Long way to go. Most of the material that we are using for preparing white LED are listed here, starting from zinc oxide to silicon carbide. Even people started using recently silicon quantum dots, gallium phosphide quantum dots, gallium arsenide quantum dots, zinc sulfide quantum dot, cadmium selenide quantum dots. But the most important thing, many material have toxicity, biological impact, recycling problem, greenhouse gas emission during the mass production. All these things you need to take care. When we prepare a material, it is decided by four legs. One, affordability. Second, availability. Third, reliability, performance. Fourth, environmental responsibility. Question is, can we create material which is energy efficient, long life, durable, cost saving, small size, design flexibility, tunability? If we can, then one day, if not today, we'll achieve. And scientist has come into a conclusion through repeated research that quantum dots white LED is going to revolutionize the entire light emitting industry. So start doing research on quantum dot materials, silicon germanium composite, silicon gallium arsenide composite, because silicon turned into optoelectronic material in the quantum phase, in the nano phase. And that's the way we can develop new material industry. So material requirements for white LED, it must be direct bandgap material. Material can be made both p-type and n-type. Efficient radiative pathways must be exist. Non-radiative pathways, phonon mediated pathways need to be reduced. Correct bandgap must be achievable by the material. So direct bandgap materials are gallium arsenide, not silicon, but silicon turned into direct bandgap at extremely small level, which is called quantum dots. So candidate materials must have readily doped N or p-type material, materials with refractive index that could allow light to come out. So refractive index of the material play important role. So here is the different band gap material that we need to create a red, green, and blue light. Remember, to get cool white LED, we must have a red, green, and blue light mixing. Either one material or multi-material must be mixed into one nanocomposites to achieve white cool LED. And that's the ultimate target, where knowledge of semiconductor physics, knowledge of quantum mechanics, knowledge of biology, because remember, biology is important, knowledge of environmental science, knowledge of chemistry, knowledge of physics, knowledge of engineering, all are needed. So it is truly a multidisciplinary area of research, and we have been doing on that. UTM researchers are really working on this multidisciplinary research, and you must also do. Indian government encourage that. Most of the university and institute like IITs and so on, when I supervise, when I look at the thesis for evaluation and so on, master's, PhD level, I see how fast, how rapidly Indian research is revolutionizing, and you are a part of that, and we must be proud about it. And that's the way our Indian science and education is progressing in the right speed, and we must enhance. And I also convey this message to the Vice Chancellor that must do something to invest more money on material research, on the research of physics and chemistry, chemical properties of material, biological material research. Entire computer science department, engineering department must be motivated to create functional materials, smart materials for tomorrow's industry, to create environmental friendly material like solid oxide fuel cell, hydrogen production, renewable energy sources, white LED material. So these should be sensors, detectors for diseases. So these are going to be the priority area aligned with the niche area of Indian government. So these are most of the important areas where light and life can be connected. Now, these are the materials which qualify the properties of white LED, zinc sulfide, cadmium sulfide, gallium sulfide. Any one of you are working on this area must be very proud about it, because job market are there, prospects are there after research. So now the new challenges for creating white LED: cost, color, directional distribution, performance of the material, life expectancy. If you invest money, you ask to the shopkeeper, how many years I will use? 10 years, 15 years? When you buy a mobile phone, you look at the lifespan. If after 3-4 years the mobile phone go bad, we don't buy it. We buy a mobile phone which should at least last for 8-10 years. Then there it is worth it to invest money. We buy a laptop keeping in mind that 10 years I can use. Every year I cannot change the laptop. When we invest money on car, we at least take care that 30 years I will be using this car, lifetime. So this is the, even when we are investing money making our house, we look at the cement quality, we look at the polymer, we look at the geopolymer, we look at the concrete, we look at the brick, we look at the paint. So everywhere nanotechnology is making revolution. I'm also working on the construction engineering, civil engineering, chemical engineering to create smart material for tomorrow's construction industry, which we call green material. So everywhere there is a shift, there is a direction change of material research. So coming to the last part, in next 5 minutes, I'm going to complete this lecture. So we need human-centric lightning system where nanotechnology and white LED makes the role. And here is the connection of light with biological supracharismatic nuclei. And the Nobel Prize in 2017 has gone into this. These three scientists showed that our regulation of the body, our sleeping habit, our disease, our circadian rhythming system, that means when we wake up, when we go to bed, when our sleep is deep, when our hormonal system is doing, how quickly we can think, how our next day would be, everything is decided by the bedroom lighting condition and how you expose to the light whole day. Most of you, maybe in the darkness light, you play 10-15 minutes to look at your message and everything on the mobile phone during bed. Please stop that. Please stop that. And I have told my student and so on this, and it is really, really impactful. This is the simple thing you can do and avoid a lot of vision problems, especially with the kids. And here is the revolution of white LED. Philips lighting system has created Sky Factory USA, stretch ceiling solution using LED, Osram designed award International Festival 2017, Scriptus TW LED. These are going to very natural. And with that, if you create the interior decoration like this, you can really bring the entire Amazon, entire Grand Canyon, entire Himalaya, entire Alps into your bedroom, into your living study room. And this is the way we can create human-centric lighting system. So the whole platform of the canvas painting would be loaded with optoelectronic white LED light chip. So they would be regulated renewable or solar energy system. So minimum energy consumption, maximum efficiency, best effect. So our health would be good, and we are looking for it. So human-centric lighting system creation require a lot of parameters, and these are the parameters we need to take care through this lighting system. And myopia prevalence and prevention, as we say, prevention is better than cure, and nutritional light source and lighting material can only prevent eye disease, namely the myopia. So to create nutritional light source, we need to create material with color temperature nearly 7,000 to 8,000. This is the criteria. So too much close works under bad lighting is the main reason for human problem, and hence eye problem means hormonal problem, brain problem, neuronal problem, Alzheimer disease, short sleeping, insomnia, all these come from light. Recent research shows it is connected to light that we absorb whole day through our retina. And there is no reversible effect. We cannot make it irreversible. You cannot make it reversible. Once this is done, it is irreversible effect. Only thing doctor will suggest, go for optical glasses, take contact lens, don't hold LASIK, because doctors are also waiting for earning. And this is the way a big size of medical professional ophthalmologists are earning money. Dental problem is connected to eyesight problem. And this really don't remove. Yeah, within 2 minutes, I am going to finish. So this is basically the white light emitting system that we have here now. Antibiotic methods, reduce close working condition, break 5 minutes every hour, increase use suitable distance of glasses, vision, go outdoor whenever possible, never read books or use mobile screen in darkness. This is the only way we can avoid the vision problem. We can save millions and billions of human health. So this is the way to create light connected to life processes. So in conclusion, I would like to say the human-centric lighting system is needed for tomorrow. That's tomorrow. Today, we are killing ourselves with bad lighting system in mobile phone, laptops, and most of the televisions, and all these habits are killing. So we need saving. These human-centric lighting systems are saving. They require low energy consumption, low cost. So saving. Another is safety. They have no ultraviolet emission, no electric shock, no glare, and difficult to burn. Strong, good health, good sleep, no mismatch of disease. They are smart, good awareness, alertness, creativeness, mood, and joyfulness you can create through this nutritional lighting condition. And they are also, most important thing, sustainable and environmentally responsive. So no greenhouse gas emission from this lighting condition. Thank you, and you are most welcome to collaborate with UTM in the direction of research, do material research, do nanotechnology. This is the future for tomorrow. Thank you so much.
Thank you so much, sir, for your lecture. We all enjoyed your lecture. So the session is open for query. Anybody can ask question.
Yes, please.
Okay.
Is there any question? I cannot listen to anyone. All are mute, it seems.
Bartwal Sahab, unmute kar lo.
Okay. Okay. If there is no question from the student side, then I would ask a query, Professor Ghoshal.
Yeah, please.
The query is, you have shown some example of semiconductor materials, either in elemental form or a composite. Is there any possibility of getting the C LED by composite materials having a very small amount of nano particles in that? That will be economic.
I request others not to open your microphone, please. Please ask the speaker to talk only, please. It will interfere and delay the session. Yeah, please.
Okay.
Your last point was, is there any composite possible
possible for getting the CLED because it will be cheaper as well as it will be easy to make.
Yeah.
Have you been in that direction?
Good. Answer to that question is, if you look at recent, you just go to the Google and see in Japan, Tokyo University Material Research Group, in Princeton, also in Caltech, and also Cambridge University Physics and Material Group, and EPFL in Switzerland. They have created some composites with phosphate and telluride based glass together with silicon quantum dots and rare earth quantum dots. 4 type of rare earth quantum dots: erbium, dysprosium, holmium. Some are using samarium, dysprosium, lanthanum. So people are creating this kind of very complex multiple mixture, very complex, I must tell, very complex multiple mixture and high purification, because no one is revealing the data. It's something like reaching to the Mars silently, reaching to the Pluto silently, meaning those who will be able to do, they will be making a revolution. And as you know that if we break the rule of government, we go to jail. If we break the rule of God, we go to hell. If we break the rule of physics, we go to Stockholm to get Nobel Prize. So everyone is looking to break that, trying to create this color rendering index between 90 and 100 using this composite, and trying to create color temperature nearly 9,000. No one is revealing at the level of defense and at the level of high secret result. The moment they will do, they will go for mass production. Immediately, the whole market would be flooded without knowing. You and me will buy. As long as customer buy, they don't care from where it came. They will say, wow, we have such a good material, completely sunlight we are getting. Answer is yes, your speculation is correct. Recently, last 5 years, people have started looking at those composites. They call it semi-metal, even graphene they are using. Semi-metal metal, inorganic, and some people are also trying inorganic, organic semiconductor nanocomposites. So probably organic LED, which Korea is using already, Japan is using in their camera and so on. Organic LED with inorganic semi-metal, metal nanocomposites, and also semiconductor nanocomposites would be the goal. But no one has hit into that limit. I said no one has gone into the color chromaticity coordinate center of the white LED spot. But yes, nanocomposite is the solution. A single material cannot give. This is sure.
Thank you. Thank you so much.
So if there is no question from student side, please student, if you want to ask, you have any query? Sign?
Yes, sir.
Sign?
I have a
You have some query?
Yes, sir.
Sign Mitra, it's from PG student. Yes, please.
Yes.
Mhm.
Professor Ghoshal, you beautifully talk about the how light is connected to the light. So, sir, I have a question about that. What is the future research that you can?
Okay. So your question is what future research you can do that I suggest so that it would be worthy. Is that the question?
Yes, yes.
Good. So I would not say big thing what Caltech, Oxford, or Kanpur IIT, or our Bhabha Research Institute or IISc Bangalore is doing, because it's not important to talk about this because you have limited facility. We must talk about science, what you have. Now, question is, if a lot of PhD students, master students are working in those areas, I would say the cheaper facility to produce material research is go for laser ablation technique. Just one Nd:YAG laser, almost all laboratory have laser ablation technique. Instead of creating molecular beam epitaxy or MOCVD or sputtering technique, those are the techniques which require more money for maintenance, electricity and many things. So go for sol gel technique, go for laser ablation technique. That can create very good material, number one. Number two, go for cheaper material, such as use glass, rare earth based material, which are plenty in India, use the furnace and so on. Now question is the facility for characterization. Production of material is one side. Characterizations are expensive. For example, a single material must be characterized 20 properties: structural property, morphological properties, optical properties, mechanical properties, thermal properties. Each 5, that means 25 characterization. ACM, TEM, HRTEM, XPS, XRD, photoluminescence spectroscopy, Raman spectroscopy, all are very expensive. You need a $1 million lab. Well, India government has given that facility. We can use inter-university consortium for characterizing our sample. But for that, you need to have the UGC or DST grant to pay. So what I would say, go for material such as quantum dots, silicon quantum dots, silicon gallium arsenide nanocomposites, metal or put plasmonic materials such as silver, gold, nanocomposite, silver, gold, together with gallium arsenide, indium phosphide, silicon carbide. These composites, because we do not know yet how one will perform. If we know everything, then research will stop. So go for any kind of organic inorganic or metallo-organic or metal non-metal or graphene based, semiconductor graphene, zinc oxide, graphene oxide, together with little rare earth doping. Any new result you can share, publication will go high, research will go in good direction, but always cheap. Use the cheaper and available method. Don't go for big ambition. That is my perception in science to survive.
Thank you, sir.
Okay, thank you, sir.
Thank you, sir. Any other questions?
If there is no question, so we must thank Professor Ghoshal for nice lecture, and which also gives another dimensions of the optical nutrition, light nutrition, apart from the minerals, water, and proteins, etc. This nutritional light is also very important, in the absence of which or deficiency of which will cause